Good afternoon, all of you. My name is Sumit Kumar. I'm second year PhD student. I'm working with Professor Bala and Professor Ashwin. Today I'm talking about a brief introduction of the geoengineering and its impact on the climate. So first thing is, what is the geoengineering? As we know from the last few decades, the emission of the greenhouse gases due to the human activities, the global mean surface temperature change increased by approximately 2 degrees centigrade. So to overcome this effect, global warming effect, geoengineering refers to a broad sets of methods and the technology which intentionally change, alter the climate system and reduce the impact of the global warming. So there is two main classes of the geoengineering. First is the carbon dioxide removal. Second is solar radiation management, which we also call the solar geoengineering. So basically, to overcome the global warming, we have two options. Either we have to increase the outgoing long wave radiation, or somehow decrease the incoming solar radiation to protect the planet with the global warming. The first method is carbon dioxide removal. So it basically focus on the removal of the carbon dioxide from the atmosphere. And in the solar radiation management, it's referred to the reflection of the incoming solar radiation by 1 or 2% back to the space. So CDR methods or techniques that address the root cause of the climate change by removing the greenhouse gases from the atmosphere. But SRM does not include any greenhouse gas reduction in their techniques. So next is what carbon dioxide removal. So carbon dioxide removal includes a broad set of the method involving the land, ocean, and the technology systems, which all aiming to increase the rate of the net removal of the carbon dioxide from the atmosphere. So CDR basically for the falls into the two categories. First is the land and the technology based CDR method, in which we either can increase our natural sinks of the carbon dioxide, or we can reduce our natural sources of the carbon dioxide. So enhancement of the natural sinks are basically the afforestation, reforestation, and the bioenergy with the carbon capture and storage, fertilization of the land plants, enhance the weathering on the land, and direct air capture. Or for the natural, reduce the natural sources, we have the biomass, fuel, and the biochar in our agriculture processes. So on the other side, we have the ocean-based CDR method, in which there is two category: either to change the ocean's chemistry or change the ocean's biological pump. So by changing the ocean chemistry, so we know that the ocean is a large sink for the carbon dioxide. So this process is called the ocean alkalinization. If we ocean alkalinization is approach to carbon removal that involves adding the alkaline substance to the seawater to enhance the ocean's natural carbon sink. Second is change in the ocean biological pump. So this process is called the ocean fertilization, in which we added some nutrients like iron in the ocean, so that the ocean organism can absorb more and more carbon dioxide, and using the photosynthesis convert it into the biomass. So there are a lot of methods in the CDR. So which method is generally considered as a geoengineering? So not all of the CDR method comes into the category of the geoengineering, because in the geoengineering we are interested in the global impact the high storage of the carbon dioxide. So here in this schematic, we can see for the land and the technology-based CDR methods, the afforestation and reforestation generally lies in the geoengineering, but in the ocean-based CDR method, ocean fertilization and ocean alkalinization is fall into the geoengineering methods. So how the ocean sinks the carbon dioxide? There is a three possible ways. One is either the carbon dioxide dissolve into the seawater and the produce a carbonate and bicarbonates. So second is marine organism absorb the carbon dioxide and use it in the photosynthesis and process and convert it into the biomass. Third is ocean circulation that takes CO2 from the sea surface, from the surface to the deep ocean. So the first one is the when the carbon dioxide in the atmosphere interact with the ocean surfaces, it then it converted into the weak carbonic acid, and this weak carbonic acid further decompose into the conjugate bases of the carbonate and the bicarbonates, and this carbonate is further utilized to absorb carbon dioxide in the ocean. Second is in the diagram we can see when the upper layer of the ocean in which the solar radiation can penetrate, some of the phytoplanktons which can absorb the carbon dioxide and changes into the biomass, and some of the carbon, which is organic carbon, sink into the deep ocean near the sea floor. Third is the ocean circulation take the CO2 from the sea surface to the deep ocean. So cold water flows from the high latitude surface into the deep ocean. It carries the gases like CO2 with it. This is called the ocean ventilation. Removal of the anthropogenic CO2 will take several centuries by this process. It also depends on the ocean circulations. On the other hand, we have the solar radiation management, which is called the solar geoengineering. It falls into three categories. First is the stratospheric aerosol injection. Second is the enhancing the planetary albedo. Third is the low-level cloud brightening. So stratospheric aerosol injection, where's the idea come from? Earlier 1991, there is a massive volcanic eruption in the mountain Pinatubo. There is 20 million tons of sulfur dioxide which goes up into the air, up to the stratosphere and stay there for a few years. By this, most of the sulfur dioxide can reflect the incoming solar radiation back to the space, which decrease the global mean surface temperature by 0.5 degrees centigrade over next 2 years. So after that there is the Nobel Prize winning Crutzen gives a statement in their climate change report. They said that the sulfuric stratospheric sulfate aerosol can reduce the incoming solar radiation. After that, this topic gets too much attention, and too many research started on it and people talking about in their conferences. Second is the enhancing the planetary albedo. If we increase the albedo of the planet by using the reflecting material on the top of the buildings and the surfaces, so we can get the more and more reflected incoming shortwave radiation. Third is the low-level cloud brightening. The low-level clouds are good, thick, and they have the temperature same as the surface temperature. They can reflect more and more incoming solar radiation. So there is the one method. If we can brighten the low-level clouds, such as the marine stratocumulus cloud, so we can enhance the reflectivity of these clouds. So the large source of this is a cloud condensation nuclei. So if we can spray some sea salt into these marine clouds, so we can, these sea salt are the center for the formation of the condensation nuclei, which can increase the cloud droplet number concentration, which further increase the thickness, so the more reflectivity. So low level cloud brightening is also uh, increase the reflectivity of the sun rays. Next is, how is the solar engineering being researched? So there is a lot of research going on the geoengineering in the past. But here I take the one of them in which they use the CME 5 models and 20 model ensembles and take the averages of all the models. So this is called the geoengineering model intercomparison project. This project goes on in many phases. There is in the one phase, they conduct the four model simulations. The experiments is named as the G1, G2, G3, and G4. In G1 experiment, they instantaneously 4 times increase the carbon dioxide as compared to the pre-industrial value, and simultaneously reduce the solar constant to offset the radiative forcing by the carbon dioxide. In the G2 experiment, uh, they increase the carbon dioxide 1% per year and gradually decrease the solar constant to balancing the changing in the radiative forcing. In the third experiment, they use the RCP 4.5 scenario, starting with the 2020, gradually ramp up the amount of the uh, sulfur dioxide and sulfur aerosol injected with the purpose of keeping the global average temperature nearly constant. In the experiment for G4, they use the same RCP 4.5 scenario, but this time they do not increase the sulfur aerosol concentration, but they increase it at the constant rate of 5 teragram per year. So here is the schematic. We can see these four experiments. In the first experiment, they increase 4 times the carbon dioxide and decreases the solar constant to keep the net forcing as the control run. In the G2, also they increase the percent of the carbon dioxide per year and decrease the solar constant to offset the radiative forcing due to the carbon dioxide increase. They run these model for 50 years and stop the geoengineering after 50 years and run also for the 20 years to see the how the forcing is react. So after 50 years, we can see the forcing against same as the previous 1% year carbon dioxide increase. In the G3, they use the RCP 4.5 scenario forcing and injected the sulfur dioxide aerosol to overcome the forcing effects to so that the net forcing is same. So in the G4, they use the RCP 4.5 scenario, same as the G3, but is this time they injection of the sulfur dioxide is constant per year. So in the phase 2, the sea spray geoengineering experiment, in the phase 2, marine cloud brightening MCB to the sea spray injection have been proposed a method of the temporarily alleviating some of the impact of the anthropogenic climate change. So here they conduct a three more model simulations. First is G1 ocean albedo. So here this is the same as the previous one G1, but here to reduce the solar instead of to reduce the solar constant, they increase the ocean albedo, and on the other side they conduct G4 CD and C G4 sea salt. So in this scenario, they they combine the RCP 4.5 forcing starting with the 2021 increases the cloud droplet number concentration by 50% or increase the sea spray emission in the marine boundary layer between 30 south to 30 north by uniform amount up to when the effective radiative forcing decreases by 2 watt per meter square. So what they get, there is a good news. It seems to work for the surface temperature, but not the precipitation. In the G1 ocean albedo experiment, we can see there is a lot of cooling in the oceans as well as the tropics. But if we saw the precipitation change, so this is the very uh, non-uniform and the precipitation decreases and the ICZ is also disturbed in this geoengineering experiment. Or second is cloud droplet number concentration. They increase between the 30 south to 30 north. So they increase the CDNC so that the uh, thickness of that layer increases or more and more shortwave can reflect back to the space. So we can see in the foot diagram in the panel, the effective radiative forcing between 30 north to 30 south is decreases. So there are some impacts of the geoengineering also. There are a lot of studies on the impacts of the geoengineering. Some of these I summarize here. The impact on the stratospheric ozone. So sulfate aerosol particle in the stratosphere gives a surface for the chemical reaction to that destroy the ozone. So substantially, we can see in the diagram the Antarctic ozone layer is more and more depleted, and it takes delay of 30 to 70 years to recover, and a substantial increase in the Arctic zone depletion, especially during the cold winters. There is also impact on the precipitation. The global precipitation decreases by the 5%. If the reduce the temperature over the tropical ocean, which will decrease the evaporation, which further decrease the precipitation. There is ocean acidification. If we pump more and more carbon dioxide into the ocean, the ocean surface, the average surface ocean pH decreases by 0.7, making the ocean more acidic. Impact on the carbon cycle also, the potential increase in the oceanic carbon sink due to the increase in the CO2 solubility due to the low temperatures. What happened if we stop the geoengineering? After stopping the geoengineering, warming start again very rapidly with the rate of 1 to 4 degree per decade, which is today is 0.2 degree per decade. So these are the impacts of the geoengineering. So the question arises, so could the geoengineering be the solution to the climate change? So argument for the acute fix to rapid warming uh, to prevent the melting the ice caps, risking of sea levels, effectively reversing the CO2 warming, which is works for the surface change. Against for the negative impact on the hydrological cycle, ozone layer once started, we need to maintain it for centuries. Failure of the implemented of geo would be catastrophic. No cure for the ocean acidification. Uncertainty in the science. Are the model good enough to calculate the effects? There is ethical and political questions also there. How would it be invented and how would we decided what the temperature should be and who would be decided? So there is a lot of study already there and a lot of study more needed to understand the geoengineering better. Thank you.
As review, any question?